everyone, welcome to another maths video by Maths with Sarah. So today we're going to be having a look at this algebra function question. So this question is a pretty challenging question. It comes from a paper 3. It's a question 26, which means it's right from the end of the paper. So we're definitely looking at the sort of grade 9, grade 8, A star style of question. And I think even just the fact that it's a function of x or f of x rather than being y equals just makes it so much more difficult for some reason. So as with all of these videos, I encourage you to pause the video around about now, have a think about how you would tackle this question. So whether or not you can do the whole question, whether or not you can think about what sort of method you would be using but aren't quite sure how to go about the full question, or whether or not you haven't really got a clue. I encourage you to at least have a go, have a start at solving this. And then check back in it once you've had a chance to have a look, and I'll go through it step by step. Okay, so we have got a function of x, f of x, function of x, and that equals 2x plus 3 over x minus 4. And the question that we've been asked to work out is to find the f to the minus 1 of x. So this essentially is inverse function. So we're trying to find completely the opposite. So it's basically finding the inverse of this whole equation. So the way that I find easiest to do this, I'm not saying that, again, with a lot of these videos, everybody has their own method. This is the way that I find easiest, and I think that you always get the right answer if you use this method. So that's the reason why I'm advocating this method, but I appreciate that there are multiple other methods of doing this. So the way that I would do this is I would say that f of x will just set this equation equal to y. It just makes it a little bit easier to deal with, so that we can start manipulating what's going on. Don't have to use y, could use a or b or whatever, but we'll use y for this. So we're going to have y equals, and I'm going to put brackets around everything so that I remember that I can't just do something with the 2x and forget about the 3. Because this is as part of an algebraic fraction, we have to keep everything together, at least for the moment, until we've removed the fraction. Okay, so with this, everybody would do this a slightly different way. In terms of where you start, there's only really one thing. So we need to try and simplify this fraction, basically. As it stands, there's nothing we can really do because we've got a combination of x's and numbers on both the top and the bottom, which just makes it a little bit difficult to deal with. So I would start trying to get rid of this algebraic fraction. The way that I'd probably do this is to times both sides by x minus 4. So if we do that, we end up with y in brackets x minus 4, and that equals 2x plus 3. So already this is starting to look a little easier to deal with. Now, kind of looking at this, again, there's a few different things you could do. The thing that I would do is to expand this bracket, and that means that we can start moving all of the expressions around. So if we do that, we're going to end up with x times y minus 4y. And then we know that that's equal to 2x plus 3. So I think probably quite a lot of people will be able to get to this step. And then at this step, I think is the point where a lot of people will be going, I just don't really know where to go from here. That's fine. The method that I use for this is to put everything on one side, set the whole thing equal to 0, and then start looking at what common factors you've got, without forgetting that what we're trying to do is rearrange this equation so that we end up with x equals, because that's how we've got that's how we do the inverse of f of x. So what we're looking for is x equals something. So it's essentially like rearranging the equation, those sorts of questions that you'd have done previously. And the way that I always do, just chuck everything on one side, look for common features, and then we'll go from there. So if we do that, we're going to end up with x times y minus 4y minus 2x minus 3. So you can see I've just subtracted 2x from both sides, and then I've subtracted 3 from both sides, and that leaves me with this long equation is equal to 0. Now, if we want to get x all on its own, the easiest way of doing this is to kind of do some sort of bracket thing. So we're going to end up with x on the outside of the bracket, something in the bracket, something on the other side that hasn't got any x's in it, and then we can do a divide. So now that we've got all this together on one side, what we can do is we can just circle the terms that have got an x in them. So this has got an x and this minus 2x here. The other two, we don't actually want anymore. We don't need those. We can move those back onto the other side, and then we can just deal with the bits with the x in it. So if we do that, we're going to end up, we'll leave the x and the xy and the minus 2x where they are. And then we will essentially just move the minus 4y out the way. So if we add 4y to both sides, we end up plus 4y. And then we'll do the same with the 3, so plus 3 on this side. And now we can start manipulating this. So we're never losing sight of the fact that what we're aiming for is x on its own on this side. And that allows us to basically turn this equation inside out, or to calculate the inverse. So now we can say, well, actually, these have both got x in common. So we're thinking about factorising now. They've both got x in common. We know that if we've got x, y, that means we need to times the x by a y. And then we need, for this expression, we need to subtract 2. So then if we were to expand this bracket, we'd get xy minus 2x, which is, of course, what we've got there. And then that equals 4y plus 3, because we've not touched this side. Theirs haven't got any x's in them. We're not interested. So now, actually, as the last step, what we can do is we know that this is the same as x times y minus 2 in brackets. So what we can do is just divide both sides by y minus 2. So if we now go back up here, run out of space, we can do x on this side, and that is equal to 4y plus 3 divided by y minus 2. So what we figured out here is we've worked out what x is. We've taken the x's from here. We've done completely the inverse. We've turned it all inside out. We've worked out the inverse, or the f to the minus 1 of x. But we've worked it out at the moment in terms of y. So what we need to do now is quite simply replace every time it says y with the x, because we've been asked for it in terms of x. And this will give us the f to the minus 1 of x. I know that might seem a little bit confusing because we've literally just got rid of the x's just to put them back again. But by far, this is by far the easiest way I found of doing these. It's just to ignore the fact that it's an x, set it equal to y, and then put the x back in at the end. And it always works. Okay, so we have got the inverse function of x, or f to the minus 1 of x, is 4x plus 3 over x minus 2. So all I've done here is just every time there's a y, I've plonked an x in instead. Okay, and this is our final answer. Hopefully that made sense. I realised that just purely because it's called f of x, if they'd said y equals this, rearrange the equation to make x the subject, probably would have been much simpler. But that's what makes this a grade 9 question, is the fact that we're using inverse functions. We've got f to the minus 1 and we're using f of x, function of x. It just makes it that much more complicated than if we'd asked you to change the subject to the formula. So I've got quite a lot of other videos based looking at algebraic fractions, looking at simplifying fractions, looking at simplifying algebra expressions. So if you are struggling with any of the concepts in here, I've linked all the algebra videos. So hopefully there'll be something there that will help sort you out. I've got another challenge question coming next week. So I really appreciate if you like and subscribe to this video, this channel, so that then you'll be able to get first access to all of the challenge questions that I'm doing. And lastly, thank you very much for watching.